Welcome to the first live lesson of 2021. We'll be having more and more of this. The reason why we have live lesson is to actually point you in the right direction for certain topics, which can be quite confusing or in terms of questions, in terms of difficulty. Okay, my job is to pick out things that students usually don't do well in and to make sure they do well in it. Okay, so if you attend the live classes, you're actually going to know certain things that you can fall and trip over and make mistakes. And the whole idea is not to fall and make mistakes like you would if you didn't attend these classes. Okay, so it's very, very beneficial. Just come along during the live lessons whenever they are scheduled. Just come, have a chat with me, ask questions, and we go through topics that are usually very tricky. Okay, and we will go through tricky parts and why they are tricky. Okay, so just 1 hour ago, I finished the lesson with P3s and P4. Some of you were attending those. Okay, we looked at this topic called fungi and bacteria. So I know most of you are in P5 and P6. Supposedly, you could even be in P3 and P4. I already shared with everyone that you could be in any level, P3, P4, P5, or P6. You can attend any one of these classes as per your interest, as per your time permitting you to attend these classes. Just come on in and you are not stopped from attending a class that is not your level. You got it? Because even P5 and P6 have to know what? Fungi and bacteria. So you could have attended 1 hour ago, am I right? Am I right? You could have attended 1 hour ago. So just look at the schedule. If there's a P3, P4 class and you're really free at that time, you can just come on in, okay? Any questions, just shout it out. Like I said, I'm trying to be more liberal here. Hopefully all of you are well behaved. All of you are older, at least 11 years old, I'm sure. So yes, some of you are 10. You want to attend, yeah, okay, good. Okay, so you guys can like just shout out answers and blah and so on, okay? So let's start. Water and its cycle, you may or may not have done it in school, doesn't matter. You will have to eventually do it, okay? I will assume P6 has already done it. P5, you will be doing it this year, okay? How many of you have not done it? Just say, I've not done it. You can just unmute yourself and just say, okay.
No, I haven't done it.
Yeah, okay, it's okay. But water is a topic that's very easy. It just comes off your tap, isn't it? You use it to eat, you use it to drink, you use it to shower. What else? Use it to wash. Okay, so what else can we learn about water in science that we don't know yet? Okay, so what are we expected to know in P5, P6, water cycle? Okay, learning outcomes. Okay, so some of you have not even known water cycle yet, right? Like haven't learned in school. So I need to show you what do we expect you to know. We expect you to recognize that water can exist in three interchangeable states. What are the three interchangeable states? If you can shout out the answer, it'd be good. Crescendo, Eastern, Pranshu, Bohra. Okay, all of you are here. You can unmute yourself and just shout out the answer if you want.
Solid, liquid, gas.
Water vapor,
Solid, liquid,
ice.
gas.
Water vapor, ice, and water.
Good, very good.
Those are the forms of water that are under the solid, liquid, gas.
Yes. So I hear answers that are solid, liquid, gas, and I hear answers that is ice, water, vapor. So if you are the teacher, which one will you mark correct? If I say, hey, students, I need you to tell me what are the three states of matter.
Gas, solid, and liquid.
Solid, liquid,
Solid,
gas.
liquid, gas.
Good.
Solid, liquid, gas.
Yeah. Solid, liquid, gas are the three states of matter. But when we refer to water, then they have specific names. That's all, okay? All objects around you have solid, liquid, gas. If you melt them to a certain temperature, you can get the solid into liquid, okay? Or you boil them or you bring it to a high temperature, you can get the liquid up to a gas. It will occur for all matter, anything that is around you. Even your phone. Even your phone, I have a phone in my hand. I throw it into the fire. If it reaches the right temperature, it will melt. Yes or no? Yes. So everything can melt. Everything can even boil off to become gas. But depends on the temperature, whether you can reach that temperature or not. Okay, so we will do more on those things like carbon dioxide, air. I know some of you asking, what about carbon dioxide? Carbon dioxide can be liquefied. Carbon dioxide is a gas, right? It can become a liquid carbon dioxide. It can even become dry, solid carbon dioxide. How many of you have heard of dry ice?
Me.
Exactly. Yeah, so dry ice is actually solid carbon dioxide is like ice. And then because it can sublime, once it achieves a certain temperature, it turns into gas. So you can see a cloud-like effect, which is used in a lot of stage productions or wherever they need dry ice. Okay, so dry ice is just one concept of solid liquid gas or a solid turning into a gas straight away because it reaches enough temperature or enough heat.
Oh, so it can actually go to liquid?
Yes, can.
Oh,
There
okay.
is a temperature at which it can stay as a liquid, but because the temperature is so high, our room temperature is 30 what? 35 degrees or whatever, right? At 35 degrees, carbon dioxide exists as a gas. So
Yes.
if you give 35 degrees, it will say, okay, I become a gas because that's my natural state at 35 degrees. If you want a carbon dioxide to be really liquid, then you got to go back to its condensation point temperature and condense it into a liquid. You can find all the values of melting point, boiling point, condensation point in a table of data in any science textbook or any science encyclopedia or any website. Everything for oxygen, carbon dioxide, hydrogen, how to liquefy them. Can you make liquid hydrogen? Can. Can you make liquid carbon dioxide? Can. Can you make liquid oxygen? Can.
Can.
So all matter can exist as solid, liquid, gas. Okay, that's
What
matter as
about
a whole.
helium?
Helium, anything. Okay, I'm not discounting the fact of anything. Anything can exist as solid, liquid, gas as long as they get the right temperature and heat. They will. Okay. So right now, in order to go for this kind of more sophisticated matter like carbon dioxide, helium, we need to first study water because water is the simplest one. Why? Because we have made the temperature scale like a degree Celsius based on water. The temperature at which water becomes ice, we have fixed it as 0 degrees Celsius. So we can say ice melts at 0 degrees Celsius. So we have this very nice number 0 as the melting point and freezing point of not anything else, not any other matter, not any other carbon dioxide, not any other oxygen, but water. So we take water as like the universal, like this is the standard. So we study water first, then we study other things. You get it? So it's just like when you study living things, right? You study animals first and plants first, then you study fungi and bacteria, which are more sophisticated, need more attention, need more thinking through, need more, okay, levels, degrees of difficulty. Same thing here. We study water first, then we take it forward and talk about carbon dioxide. So we will, okay? So water starts boiling at what temperature? We talked about melting, 0. What temperature does it boil at? All of you do boil water, don't you? Using
Yes.
a kettle. Yes, very good. Yes, I hear
I
yes.
have a question.
Yes, please.
Actually, everybody says that, like in school, everybody says that water is one of those things that can exist in all three states of matter. That's why we study it first. But then, since now you just said and you clarified my question that everything can exist in all three states, then why don't we start with that also?
Yeah, that's why I explained because of the number 0.
Oh, okay, yeah.
Yeah, because we
It's
can tell that, hey, you
easy
can
to
tell that
remember.
if I say carbon dioxide is going to melt or condense into a liquid, what temperature? Hey, I don't know. Let me check. I go to the book, I check. I go to the website, I check. Water, do I need to check?
No,
Why?
you can remember easily.
Exactly. So that's why we start water. Understood?
Oh, okay.
Okay.
Okay,
Same
thanks.
thing for boiling. It happens at a very, very beautiful number, which is what?
100.
100. So the beauty
Century.
of this 0 to 100 is why we take water first, so that every one of us can study easily whether you are a science expert or you don't know science or you are a math expert, if I tell you about water, you're going to understand very well. Okay, so that's why we take water. Okay, let's move on to my slide. My slide, we have covered the first point. Second point is, you read it yourself first. Describe how heat gain or loss affects the state of water, which is bringing it up to 100 degrees or bringing it down to 0 degrees. You are actually introducing the word or the term or the concept of heat. Can you bring up the water to 100 degrees without giving it heat? You must give heat.
No.
Yeah. You must heat it up somehow. You on your stove and put it on top of the flame, which becomes very hot and 100 degrees, the heat gets into the water, or you put in a kettle. How come kettle can also bring the temperature to 100? There's no flame. How do you think it becomes hot? How do you think the kettle makes the water hot?
By heating it.
Using what? I know if I put it on my
Heat.
stove,
The
I use a
water
flame.
gains heat from the kettle's heat.
How does the kettle get hot?
It produces
energy.
heat. Produces heat.
Produces heat without connecting it to anywhere?
Electricity.
Very good.
Oh.
That's what I'm looking at, right? Now, if you put it on the stove, STOVE, the stove where you cook your curry and you cook your soup, you can put it up there. The heat comes from the flame because fire is hot. All you need to do is create fire. To create fire, you need some gas. There's some gas. You ignite the gas. There's some flame. The heat comes from the flame because you all know fire is hot. Okay, that's it. But kettle, there's no fire. So therefore, it depends on another kind of energy, which is electrical energy, which comes from the power socket. You connect, you on, the electricity runs through the kettle and heats up the kettle. All of you said it will heat up the kettle, but how does it heat up the kettle? Is there something inside or under the
Using
kettle?
electricity.
Yeah. What does the electricity heat up? Is it like a piece of paper or wood or something? Or is it a metal?
The metal.
Yes. There is a metal.
And since
embedded-
metal is a good conductor of heat, it
Yeah.
gets hot fast.
Yes, electrical energy convert to the heat energy. So the water is actually getting into contact with a metal, which is heating up the water until it reaches 100 degrees. The moment it reaches 100 degrees,
Metal
The
is a
kettle-
good
Yeah.
metal
the
is a
kettle
good
automatically
conductor of
switches off, means
electricity
100
also.
degrees has been reached. Yeah, very good. So you guys are getting the concept, you see. That's why we need to play with water first, because all of you can see water boiling at home every day. But you cannot see carbon dioxide boiling at home every day. So that's why we need to do with water. Okay, let's
That
go.
is so unusual.
Okay, next. You need to understand the terms melting point of ice and boiling point of water, which is very easy. We haven't talked about the temperature yet. We're just talking about at what point will water is in liquid state, right? At what point will it become a solid? Which means it becomes ice. It's called melting point. At what point will it become gas?
100.
Yeah.
100
So,
degrees Celsius.
so that's called a boiling point. Okay. So all these terms are important. Then we go into the difficult part. Those are the easy parts. Now look at me. I already changed slide. These are the difficulties which our students face because they don't know what is evaporation. They don't know what is boiling. Am I right? What's the difference between evaporation and boiling? Anyone knows?
Evaporation can occur at any temperature while boiling must occur at 100 degrees.
Degrees Celsius.
Excellent. Was it Jovia? I heard Jovia and Crescendo, right? Thanks for the answers. Right. Infer the factors affecting the rate. So if evaporation can occur at any temperature, we can probably affect how much evaporation can happen. For example, I have a bottle of water. How many can you see me holding a bottle of water?
Oh,
So you
me.
can't see
No,
very
not.
clearly. Now can?
Yes.
Okay. Now, if I open this water bottle or close this water bottle, can you imagine any amount of water will reduce inside this bottle?
Yeah.
Maybe, maybe
It
not.
will evaporate.
Very good. Am I even boiling it? No.
No.
I just leave it on my table. But if I boil it, can I make all the water disappear?
Yes.
Yeah. So boiling is different from evaporation in the process where I actually apply heat. I can purposely apply heat to make it boil, which means I'm causing the temperature to rise all the way to 100. Or I leave it in my table for a few days, even 1 week, make it open especially. Close, I don't know. Close, you know why it won't reduce? Because whatever water is trying to escape gets condensed back inside. So you must leave it open. So that means it must be exposed to air. So one of the conditions for evaporation should be exposure to air. Okay, so these are the factors affecting evaporation. We will look through them.